Okay, boys and girls, this is lesson 23 of Module 3, where you use division and what's called the associative property to test for factors, and we're going to look at some patterns. Let's look at our application problem. Sasha says that every number in the 20s is a composite number because 2 is even. Amanda says that there are 2 prime numbers in the 20s. Who's correct? How do you know? Well, what I did is I listed all of the numbers between 20 and 29. And if you look, I listed what other factors I could think of. I didn't list 1 times the number because they all have that. However, 23 and 29, I can only think of 1 times the number. So 23 and 29 are prime. The other numbers are all composite. So Amanda's correct. Sasha's only looking at the tens place. You have to look at the value of the entire number, not just at one of its digits. 23 and 29 are prime because there's only 1 pair of factors, or exactly 2 factors. Remember, a pair means 2. Okay, so we're going to use division to find factors of larger numbers. 28 equals 7 times a number. This is a basic fact. 7 times 4 is 28. Now, as you get into larger numbers, for example, is 3 a factor of 54? You can simply use division to figure that out. If we go through and do long division, 5 divided by 3, you can get one group. 1 times 3 is 3. 5 minus 3 is 2. Bring down the 4 because now you have 24 ones. 24 divided by 3 is 8. Then you multiply. 8 times 3 is 24. So yes, 3 is a factor of 54 because 3 times 18 is 54. Is 2 a factor of 54? I did the same thing. I went ahead and divided. 5 divided by 2 is 2. 2 times 2 is 4. I have 1 10 left over plus the 4 ones that were there. That's 14. 14 divided by 2 is 7. 7 times 2 is 14, and I have nothing left. Just so you know, 2 is a factor of all even numbers. So 2 is a factor of 22. 2 is a factor of 102. 2 is a factor of 98. 2 is a factor of 88. Okay, and so on. Okay, we can use this associative property to find additional factors of larger numbers. So let's keep working with 54. Now, do you need to divide to figure out if 5 is a factor of 54? No, you don't, because if you think of your 5s tables, all of those numbers end in 0 or 5. 54 doesn't end in 0 or 5. Therefore, 5 isn't a factor. Okay? Now, is 6 a factor of 54? Well, yes, it is, because one of your basic facts is 6 times 9 is 54. So let's look at this number sentence. 54 equals 6 times 9, which also equals 2 times 3 times 9. This sentence is true, because what I did is I broke the 6 down to 2 times 3. Well, 2 times 3 is 6, times 9 is still 54. I did put parentheses around it, and this is what you will see when we talk about the associative property. We're going to talk about parentheses, and we're going to move them around a little bit too, as you will see. Let's take a look at this. 54 equals 6 times 9. Well, I'm going to rewrite 6 as 2 times 3. I'm going to move the parentheses over to here. So now I have the 3 times 9 grouped together. So now I have 2 times 27. Well, 2 times 27 is 54. So if I look at all my factors of 54, I have 1 in 54. I have 2 times 27, which I have right here. I have 3 times 18 because I divided, and 6 times 9 because that's one of your basic facts. So very quickly, by using the associative property and moving my parentheses, I can find factors of larger numbers. look at 42. One basic fact is 6 times 7. I can rewrite the 6 as 2 times 3. And I can move the parentheses over so that I've got the 3 times 7 grouped together. Well, 3 times 7 is 21, so 21 times 2 is 42. I can do it another way also. I can rewrite 6 again, and I can move the order of my numbers around and group the 2 with the 7. 2 times 7 is 14. Therefore, I have 3 times 14. Well, 3 times 14 is 42. So my factor pairs for 42 are 1 and 42, 2 times 21, 3 times 14, and 6 times 7. Now, you can use division or the associative property to find factors of larger numbers. I went through and used the associative property because I want you to see how using this is rather efficient than just choosing a number, dividing it to see if it's a factor. So I stuck with 12 times 6 is 72. So I wrote it here. I decided to rewrite the 6 as 2 times 3. I moved my parentheses over, so now I have 3 times 12 grouped together. Well, 3 times 12, I can do in my head, that's 36. 2 times 36 is 72. If I come over here and take 6 times 12 again, I'm going to rewrite 6 as 2 times 3. But I'm going to move my parentheses and change my numbers around. I still have a 3, a 2, and a 12. I'm just grouping them differently. I'm grouping my 2 times 12. Well, 2 times 12 is 24. So 3 times 24 is 72. I'm going to try it another way. I'm now going to rewrite the 12 as 3 times 4. So now I have 6 times 3 times 4. I'm going to move my parentheses over. So I'm going to group the 6 times 3. 6 times 3 is 18. 18 times 4 is 72. As you can see, simply by choosing a basic fact, you can rewrite the factors in some cases, especially with larger numbers. This is a very helpful way to do it instead of just trying to divide numbers.